All right, so this will be a rerun of lecture 1 and 2 because there was a few problem with WebEx, and apparently the recording is gone. We only have whatever we have left when I reconnect on last Wednesday, basically when my internet get cut off. So let's actually do a full-blown recap of the week ago on lecture 1 and lecture 2. So from Monday, we talk about what is exactly a computer. It's a computer, right? So if you think about it, anything that we call a computer nowadays, generally what they have is it takes certain inputs from some input devices like a keyboard or a mouse. And then there is a processor that process your input in order to show some output to your output devices. These can be your monitor, for example, it can be a speaker, or it can even be something like your hard drive, where you store a file that you just save, right? That you work on, you save onto the hard drive or a storage element. It can even be something like a network. This can be a part of the output devices. Then, uh, during this process, there is also a main memory, the DRAM on the memory that you have to buy in order to plug them onto the main board, on the motherboard, right? Some of these will be for 4 gigabyte, 8 gigabyte, or up to 64 gigabyte, or even more in a large cluster of machines, right? Think of this main memory as a scratch pad. Why is that the case? Basically, when you process information, you need additional storage area to store partial results in order to produce the actual output. And these are computer. So at the end of the day, many things around you nowadays, like your game consoles, your phone, your laptop, your desktop, all of these are considered a computer. Even the small devices that goes into how you control the air conditioner or the elevator, these are also a part of the what we usually understand as a computer, right? So, in this class, we will actually dive deeper into, okay, let's look at the computer and then let's try to understand what do we mean when we talk about the system. And the first concept that I want you to understand is what's conceptually what is an operating system. Right? So if you look at it, you as a user, the way you use a computer is basically you need to interact, right? Either through an application to control the hardware, or you move a mouse to put something on the keyboard, and somehow that hardware respond to your command. Right? This is this figure that I'm showing you right now is basically what constitute in a high level, in a really most coarse-grained high level sense, what operating system is doing. Basically, from the user point of view, you can either talk to the application, which will then talk to the operating system, as you can see here, or you talk directly to the operating system, Windows or Linux or Mac OS or iOS, right? To talk to the hardware. So you can see that there's these additional layers between the operating system that protect the user from having to directly control the hardware. Why is this good? It actually abstract out a lot of things you have to actually do. It make your life easier as a user. And then on Monday, we talk about Unix, right? What is Unix? It's basically a multi-user, multitasking operating system, or OS. Multi-user literally means that there are many users that can use the computer at the same time. It allows, think about this, it allows many users to use a server at the same time, right? I can log in to the server, someone else can log into the server, and this is a big the fundamental concept of how cloud computing works. It allows you to use the resource while the other people also use the resource. Uh, Unix has multiple versions, such as Solus, AIX, Linux, and many other things. Linux is probably one of the more important ones because it's actually getting really popular in many use cases like scientific technical application, cloud infrastructure. Linux is also commonly used in a lot of IoT devices. And obviously these days there's a lot of PC and workstation that would install Linux. Part of it is because that part of Linux is free. You don't have to buy the operating system like Windows to use your machine. Linux come at many different distribution. This can be CentOS, Ubuntu, Fedora, Debian. These are some example of Linux distribution. So you can actually develop your own distribution if you will. You can just basically download the Linux core source code, build your own distribution, and release it so that people can use it. Then there's another concept called terminal. What is a terminal? Basically, it's an interface. Um, it emulate basically the video terminal within some other display architecture. This figure would help trying to make it a little bit easier to understand because actually the bullet point is cryptic, right? So think about it this way: you have a computer, as I shown earlier, right? Input device, processor, output devices. But let's say that, well, these are keyboard input and display output, but you're logging in from somewhere else, right? From other machines. You think of the host site or the server or target computer that you log into and using right now as having their own input devices, output devices, processor. And then terminal allows you as a client on your own computer to interact with the input devices that are actually physically on the other side, right? So it makes you it allows you to be able to put in the keyboard inputs and see the display, they see the outputs. And please note that you can also open a terminal on your own machine to control your own machine as well. One more thing is program versus processes. Program, think of it as it's a program as you know it. Basically, it's a binary code that contains machine's instruction. For example, Chrome is a program. A process is running instance of a program. Let's say you open Chrome, you're opening the 20 tabs. The 17 tabs on Chrome is one process. The fourth tab on Chrome, which may be running YouTube, is another process. There are two different processes that spawn the same program. So think of it this way: a program is just a binary data. A process is when you actually run those things, and it can be a multiple copy of the same program. It can be different copies of different programs. Shell is a program basically that takes your command from the keyboard and give them to the operating systems. So if you look at this diagram again, basically this is what shell is doing. You as a user want to feed in command to control the hardware. Shell would feed that to the OS. The OS would then give it to the hardware. This allows you to control the OS directly. This basically allows you to run commands. So in the bit in this lecture, we'll talk about how do you use Linux command. This has to be done through shell. In this figure, we show that hey, let's say there's multiple user. Each user can have their own standard input and standard output. They interface through shell. The shell, which sit within the OS and the kernel, would then tell the hardware exactly what to do. The difference between shell and terminal is this. Basically, if you look at the local machine, your own machine, let's call this own machine a host, right? The host OS has their own shell, and there's a terminal. The interface between human and the OS is done through terminal. So you put in the inputs, the input gets fed to shell, and then shell would command the OS. Remotely, let's say you want to log into some server to run your own experiment. What happens is the host has its own hardware. Then the shell on the host would feed the command to the host OS. And because you have to log in from somewhere else, right? So your machine would have a program called terminal, which send the command to the host, which in that case, once you establish this connection, it allows you to send the command through the terminal, which then feeds to the shell, which then will be run on the host OS. And some more on Linux. Now that we talk about shell versus process, terminal program versus processes, let's dive deeper into Linux. This is actually the start of lecture 2. So we actually spend quite a lot of time talking about administrative things on lecture 1. If you still have questions, feel free to check the slides and see, just email me the questions. Now let's dive deeper into how to use Linux. So the first concept is Linux. Inside Linux, everything is a file. A program is a file, a data is a file. Even a directory is considered a part of the data. Everything is stored in files. Files are then organized into multiple directories. Or if you want to have the same analogy from Windows and Mac OS, those are folders. The folders that store the files is equivalent to directories. This is one example where you have a root, not a root, my bad. You look at this particular directory on var/var/logs. Then you can see there are multiple files. Each file contains certain it contains certain data. If you see this apt here, this is a program, and the rest are basically data. So what you can see here is both program data, zip files, or whatever are stored in each directory in a file format. Files and directory are organized in tree-like structure, starting from root and go for downward. Root is basically the backslash, like the most upward, like this is the root of your whole directory structure. Think of it as the C colon slash slash in Windows, and then each files inside that folder can contain more folder. So you can have another folder that go deeper into a different folder. It can contain files in there. The extension of the file doesn't really mean anything until you actually need to use the program to run the extension. It's just a piece of data. Space in the file name is also okay, but you want to make sure you have this escape character, the backslash. What does backslash mean is treat whatever comes after the backslash as a part of the file name. Basically, when you have the escape character, generally what it means is treat that thing that comes after this escape character as a part of the string. Right? The string as you know it when you write the program. So another thing I want to tell you is anything that starts with a dot, hidden files and directory, basically it would hide when you list out the content of the folder unless you specifically said list everything or have the -a when you put in the command ls. One more thing about the Linux file structure is every single file is associated with a path. A path tells you how to get to the files. Think of it as a home address, right? So I can put in the absolute path, my full address. If I give you my full address, you should be able to somehow navigate wherever you are and arrive at my house. That is the absolute path. It starts from the root, which is the slash, right? Down to where the file is, or down to where the folder is. Then you can have the relative path. Think of the relative path this way. I know where you are. I would just give you direction from where you are to my house. Go out, turn left, turn right, go straight 3 blocks, turn right, and then you arrive. These are relative paths. It starts with wherever they are. So it can be the dot slash or the dot slash. Dot slash means that start from current directory. Dot slash means that go back one directory. So every time you see 2 dots, it means that go up one level, right? So there are some special paths when you want to refer to certain places that are really commonly used. Tilde refer to your home directory. This is where you start when you log into a server and where you start when you start a terminal. Dot refer to what we call a working directory, which is where you are right now. If you are browsing different files in a computer, dot means that it's current location. Dot means that go up one level, go to the parent directory. Slash means that we go back to the root directory or the topmost directory. So these are the special paths that you can put in when you have to deal with the file structure of Linux. The basic commands are in this format. You put in the command name followed by any number of arguments based on the command, how the command is used. For example, if you want to list every single file and directory in the current directory, you can do ls. -ls means an option that will say list everything in details. So let's say you use ls-l followed by the target, such as the home directory. In this case, it would list every file and directory in your home directory. If you don't put the target, it means that you are going to list the current directory. cd target literally means that change directory to a target. Make directory mkdir with directory name, basically create a new directory with the name that you put in. rmdir, which is going to remove the directory. Make sure that when you do rmdir, the folder or the directory is free. There's no file in it. Otherwise, it would say, hey, there's something in there, and would not remove the directory. If you want to move from somewhere from source to destination, then you do mv source destination, which allow you to move and also rename by using source and a new name. cp, which allow you to copy from source to destination. You can actually add -r, which means that I'm going to copy everything in that folder to the destination. rm, which doesn't have destination here, it should be just rm and source, means that I'm going to remove the file or directory which goes in here. That can be multiple files. You can list multiple things in here, or you can use -r, which means that delete the folder and everything that goes inside that. Touch means that I'm going to create an empty file called file name, and you can use wildcard. Star refer to everything, slash you can use slash between each directory level. So let's say you have /full/store. This basically means that you're going to refer to files and directories under full, everything that goes in there. Wildcard can have different formats. As we said earlier, store means that it represents everything, 0 or more character. Question marks means that it's one single character. Bracket means a range of characters. So here are the example. ls-l a star question mark means that it would match anything that starts with an A, followed by at least one character, because we have the question mark there, and then followed by any number of character, as we can see here, right? Then the mvu bracket 6 question mark means that I want everything I'm moving to start with a U, followed by 6, and there should be at least one 6, followed by anything that comes afterward. This particular command would then move the content inside public HTML with anything that has dot, right? Dot, followed by 2 letters and G, which if you do this, one thing that can happen is any image files will be moved to public HTML/image, because JPG, PNG, or those files tends to have 3 letters that ends with the G. Man page is one of the more important command, which is basically print the manual of the command you put in. So you can do man ls, man cd, man mkdir. It would list out all the possible options that you could put in there for each command. The command cat means concatenate. Basically, you combine contents of multiple files into one. Find files or files. pwd would print working directory. Basically, print the current path of where you are. Grep search for a keyword in the specified files. So one of the really common commands that I use that are useful when you need to develop a program in a big infrastructure is I would do this. Grep -r followed by the keyword I want to search, followed by directory name. What does this do is it would search for every single occurrence of keyword in every single file in those directory. Why is that useful? It allows me to actually find the content I want to see and get print with the correct line number on the file that contains the keyword. It allows me to search for where to develop program a lot easier. Uh, then we need to talk about redirection. Redirection literally means that you redirect the input, the file as an input or output. For example, cat a.text, b.text, c.text, and then this greater than sign into output.text would create a new file called output.text, where inside will be the output of what the command cat a.text, b.text, bc.text is. Basically, you concatenate and copy into output.text. You can use the double greater than, which would, instead of creating a new file, you append the result to the current output.text. You can then use the less than sign to redirect a file, but now use it as an input to your command instead of using that file as an output. Another thing that I want you to understand is the pipe command. Basically, you can use the vertical line to forward an output of one command as an input to the next command. So let's say you want cat files forward to WC, which is word count. What it does is it would actually perform a word count on a file. Think of it as this. You have two commands and you literally create a pipe that allows the output flow directly into the input of command 2. User and groups are basically how Linux manage different users that want to use the computer. Users have different types. It can be a regular user or super user. Super user, think of it as a god. It can do anything inside a computer. It can be harmful, but it has a lot more control. User belongs to one or more groups. It can be an admin, it can be a sudoer. Sudoer basically means that you can be promoted to a super user. Sudo, usually SU stands for super user. You can create a new group with any name. You can use group followed by the username to check what group the user is in. Then user under sudo group, as I said earlier, can become a super user whenever you type in sudo in front of the command. Ownership is basically allows you to control who can read, write, and execute each file based on owner, group, and everyone else that use the machine, right? By default, when you create a new file or a new folder, you are the owner of the file / folder. Then you can change it using chown, change ownership. Each file has a group. Each file also contains 3 permissions for each particular group of users, and that applies to owner, the group that the owner belongs to, and everyone else. So here are the example. As you can see here, there are multiple files in the folder that contain multiple directories. As you can see, RWX, the first 3 bits correspond to what the owner can do. So the first 3 bits, the first 3 letters you see here correspond to the owner can read or write W and execute that particular directory. The D stands for directory. Then you can see that the next 3 letters only have the R, means that the group, which is student, right? So this is a group, this owner. The group can only read the directory, and then everyone else cannot do anything, because if you look at the rest 3 letters, there's nothing there, means that you cannot read, you cannot write, and you cannot execute. Super user and root are basically the most privileged user inside the computer. It's an all-powerful being or God that can do anything. It can be harmful, it can be good. This is called a root. And then the su command allows you to switch to a super user, but you need to put in a root password. If you just want to promote yourself, while you're running certain commands, think of it as when you want to install something on your Windows machine, you hear a ping by by Windows, and then it would ask like, can I have the admin access? It's exactly that. When you type in the sudo command, you're asking for the admin access to perform whatever commands you just type in as a super user. Don't ever use the account root casually, right? This is amazingly common in this country, and don't do it. It's stupid. It's actually extremely dumb. The reason behind that, there's a lot of things that can go wrong if you use a root account that cannot be reworked because you are the most powerful being inside that environment, and you're modifying something no one else can modify, which means that you can accidentally crash a computer or have some catastrophic results if you just keep using root as a normal user account. Is a cartoon example from XKCD that talk about what happened when you had run sudo. So let's say I want to command someone, say, hey, make me a sandwich. That person will be like, why do I have to do that? And I can say sudo make me a sandwich, and that person will be like, sure. Okay, joke aside, let's talk about another command which would modify who can access files and directory in what way, right? It's called chmod. It changes the permission of the files, and you must be the owner of that file or the super user to actually use that command. The bitmask goes it basically contains three numbers. The first number is for the owner. The second number is for the group. The third number is for everyone else in a computer. The number that goes in there are based on the permission you want to give. If you want to allow that particular set of user to read that files and folder, you add 4. Write, you add 2. Execute, you add 1. So if you think about it, this can go from 0, which is no one can do anything, to 7, which is you can do everything. And the example here is if you do chmod 777, means that now everyone in owner group and everyone else can read, write, and execute test.txt. 742 means that you as the owner can read, write, execute. The group can read, everyone else now can only write to test.txt. So, question, I just said everything is a file in Linux, right? Which means that the program that runs your command is a file. Which also means that the file is somewhere under root, right? The root folder or slash. But then when you run something, you need to provide the path to where the program is. Otherwise, Linux would have no idea where to start. Which also means that somehow there's a magic that happens in Linux that allow you to find the command, right? Because when you type in ls, when you type in cd, it knows exactly where the ls program is. This is called the path variable. The path variable, think of it this way, your shell has a variable that associated with some pre-configured values. This is called environment variables. Path is one of them. It contains multiple directories that are separated by colon. So if you actually look at what's the content of the path variable, you can see multiple directory listings. Each one of them are separated by colon. ls is actually stored in /bin/ls, which means that in this case, if you want to run ls, the path must at least contain /bin. To check where the command is, you can do which would allow you to put actually list out where is the location of the command you just type in. So let's say you use which ls, it would show up /bin/ls. You can use the export command to modify the content of the path variables. Let's say you install a new program. One thing you can do is to make sure you can run, say, Python. Just by typing in Python, you can modify the path directory to wherever you install Python. This can be done by using export path equals $path. Dollar signs means that I'm going to refer to that value inside the variable. So let's say the path right now contains /bin/ /bin /ls, right? Then it'll be /bin colon / whatever comes next, and then this whole command will add /home /lashada /bin to the path variable. All right. So here's an example. Let's say the path contains three directories: /user, usr/bin, and /bin/usr/sbin. When you run a command, it will first search this folder, followed by searching this folder, followed by searching this folder for the command. Whatever match first, it would use that exact program to run your command. If it doesn't exist in any of these folders, it would say command not found. The echo command allows you to print whatever comes next, which means that you can do echo $ environment variables, which would allow you to print the content of, let's say, the path variable. Right? So let's say you do echo hi, it would literally print hi. The usefulness comes from when you have variables and you want to echo something. So you can do echo $path. A little bit more about how you control the process is basically, if you think about it, when you run a program, it's run under a certain corresponding environment, right? The environment variables include the path variables. Each process would have a unique process ID, a parent process ID, a user and a group number, and a priority. Why is that important? Have you ever run into a case where something hangs? There are commands that you can check the process ID and kill that hanging program. So to actually manage process, you can run a top command, which would give you something that have a real-time data of all the running processes. Think of it as, here, there's a task manager for you. PS command would list all the running process. The difference between top and PS is not dynamic. You type in, you get output. You type in again, you get the output. Top, when you run that, it will keep showing what's running, and then you actually have to exit to actually go back to the command prompt. The command kill would literally kill the process. The command jobs will list the current jobs that run in the background. FG would move background process back to foreground, means that you're going to keep running and resume as a foreground job. Control C will pause the current foreground process and move it back to the background. So here's an example of how you use PX. A common usage is, hey, I want to list every single process that every single user is using. This is done by PS AUX as an option. The three letters means that A means I'm going to show process from every single user. U, display process, user, and owner. So you know who is running what, right? So you can actually run this command, and the X will basically show every single process, even though they're not attached to any terminal. And this is the result. In this case, you can know that, okay, who is using what, what's the process ID, how much CPU that the process is using, how much memory the process is using, what is the time and the command that running. Right? So this allows you to actually observe who is running what and who is using all my CPU or who is using all my memory. Here's some example of how you actually kill a process. Basically, the process of getting rid of a program that are running on your computer is to send the signal called sigkill. Basically, if you want to if you put in kill 1 2 3 4 5, it will kill the process with the process ID 1 2 3 4 5. This is useful to terminate like things like buggy programs that never finish, or zombie processes that the parent get killed and somehow the child is still there running something that's not actually being used anymore, to free up resources. Other more useful command is things like wget, which allow you to download files from the internet. You can do zip and unzip to compress and decompress files. You can use tar, which is basically packing multiple files into one single file. Think of it as almost like a zip, but you don't perform compression. You can also use the tar command to do compression. And to be honest, I never use zip and unzip. I just always use tar to compress my data because I don't remember and use multiple different commands. You can use curl as a HTTP client. Head and tail basically display the first end line or the last end line of a file. The up and down arrows basically allows you to cycle through all the previous and the next command you put in. The tab keys will autocomplete the files and folder names if it's possible. Basically, it would seek if that's the only option you can put in, and you hit tab, it would complete it. Let's say inside a folder, there's a file that has my last name, which is kind of long, right? So I can do AUS and then tab. It would autofill with my entire last name because there's a file with my last name exists on it. Control C would stop your current program. Control R would search the command history. Control L will clear your screen. You can also deal with multiple names. Let's say you have a program and you name it ls and you want to run this program. If you type in ls, it would literally go back to /bin/ls, which is not your intention. So in order to actually run this new program inside this folder called ls, you need to actually provide the full path, which means that you have to do /ls. Otherwise, it'll go back to /bin/ls. For executable, basically you can use shell to run a valid binary file. Right? Things like a program that's compiled and built for the machine. You can run scripts, which we will actually talk tomorrow when we cover shell scripting. This is going to be a bash script, Python script. The way the Linux can tell what kind of script you're running is we would use something called shebang, which is basically the !! sign. So if you do !!bin/bash, it means that run this script using bash that is stored in /bin to perform everything that goes in the script. If you use shebang /user/bin/python, it basically tells Linux so to use that Python interpreter to run your script inside the files. The executable must have the executable flag on the file so that you can run it. If you don't have the X permission on that file, there's no way Linux allows you to run the program. So you can do chmod plus X file name to add the executable flags to allow Linux to run that program. Alright, that's basically the end of this lecture 1 and 2 recap. I hope this is basically this replaced the actual lecture that we had last week. And then if you have any questions, feel free to email me. I'll try my best to respond as quickly as possible. And then I'm looking forward to tomorrow so we can cover shell scripting. And that's it for today. And thank you so much.